So now I'm going to work through a pair of practice problems. This first one is calculating the delta H for the reaction shown below. We've got C2H4 plus 6F2 yields 2CF4 plus 4HF. We have a total of four different partial reactions. I'm going to label them A, B, and C. And what I'm going to do now is basically look at those individual reactions. Again, I'm going to label these A, B, and C. What I wanted to do here was I wanted to give myself a little bit more space with which to work. So what I need to do is I need to match some of my reactants in my overall reaction, which I'm going to label with star, and I need to match those reactants and products to my individual partial reactions. So if I look at reaction letter A, what I see is I've got F2, I've got H2 as a reactant, and I've got HF as a product. Whenever I look at my overall reactions, the only things that I see that are common are F2 as a reactant and HF as a product. When I look at reaction B, what I've got is, well, I don't see carbon as a reactant or a product in my overall reaction. So what I'm doing is I'm looking at my individual reactions and comparing them. So I've got 2F2 and CF4. Well, CF4 is a product in that. Then finally, my last reaction, reaction C, has C alone, a solid carbon. That's not reacting, or that's not a reactant or a product. And I've got H2 as a reactant, and I've got C2H4. Well, I don't see that H2 anywhere. That C2H4, I only see that as a reactant. So what is that? What does Missy Elliott tell me about reaction number lettered C? Well, that's the one that I'm going to flip in reverse. So I'm going to write C2H4 yields 2C plus 2H2. And I've got a delta H here that is going to be negative 52.3 kilojoules. Okay, so what I want to do with C, I want to scribble it out because I do not need to worry about that. I'm done with that. I do not need to worry about that at all. Okay, now whenever I look at all of my other reactions, well, now I've got all of my reactants and my products accounted for, because in reactions A and B, I have F2 as reactants. I've got in reaction C, I've got my C2H4, and then my products, well, my CF4 is a product in reaction B right here, and HF is a product in reaction A right there. Okay, so I've got everything accounted for, but one thing that makes it a little bit complicated is the quantity. Okay, so whenever I look at all of these, well, what I want to do is I want to say, what's my coefficient in front of my F2? Well, my F2 should have a 6. And what I've got is a coefficient of 1 and a coefficient of 2. Okay, so the question becomes, what should I double? Or what should I triple or anything like that? Well, let's look at my other reactants, or my other products. I've got HF, and I need to have a 4 in front of that. So 2HF. What I can do with this is I can take my reaction that I've labeled A and take the H or delta H of it and multiply it by 2. Because what that does is it just changes my 2, or it just doubles everything. So that's 2H2 plus 2F2 yields 4HF. Now, what does that mean for my delta H? My delta H is now going to be negative 1074. Okay, again, I can scribble this out. I do not need to worry about that reaction. Now, my last reaction is C plus 2F2 yields CF4. Okay, so my CF4, my product here, I need a 2 coefficient in front of that. So again, I can take my reaction, my delta H value, I can multiply these by 2. And if I change, keep in mind this is a reflection on it's an extensive property. So whenever I increase or I double my reactant quantity, I'm doubling my delta H. So that's 2C plus 4F2 yields 2CF4. And what does that mean for my delta H? My delta H now has become negative 1360 kilojoules. Okay, so I can scribble out my original B, and now I can basically just combine all of my reactants. And the way that I like to do it is I like to have my arrows for my reactants and my products. All of my reactants, I've got from my reaction A, I've got 2H2 plus 2F2. Okay, from reaction B, I've got plus 2C plus 4F2. And my final reaction C, I've got C2H4. Okay, now my products. From reaction A, I've got 4HF plus 2CF4 plus 2C plus 2H2. And that accounts for everything. Okay, so I've combined all of my reactants, I've combined all of my products. What I want to do is I want to combine my reactants, or I want to look at my reactants and products. Well, lo and behold, I see 2H2 as a reactant, and I see it as a product, so I can eliminate that. I see 2C as a reactant, and I see it as a product. Then I'm left with 2F2 plus 4F2. Heck, I can combine those, and that's 6F2. And then add that to C2H4 yields 4HF plus 2CF4. My delta H overall for this is going to be negative 1074 plus negative 1360 plus negative 52.3. So my math for that ends up being negative 2486.3 kilojoules for that overall reaction. So for this overall reaction right here, delta H equals negative 2486.3 kilojoules. Okay, so lots of this is really just trying to figure out which of the reactants I need to consider, which ones I need to manipulate, and everything like that. So I'm going to do another example in the next few slides, so keep that in mind. And we will, if you want to pause, take a break, you're more than welcome to right now. But I'm going to be doing another reaction right now. So my next reaction is calculating the delta H for the following reaction of F2O3 yields, or plus 3CO yields Fe2Fe plus 3CO2. I've got these individual partial reactions. Fe2O3 plus CO yields Fe3O4 plus CO2. Fe plus CO2. There you go. I'm going to label those all A, B, and C, and I'm going to look at those in just. All right. There's no doubt about this is a challenging problem, but it's challenging only because of how you start the problem and how you could start the problem incorrectly. The way that you should approach this problem is by looking at the very first reactant in the very first overall reaction and the very first partial reaction. When you see that coefficient of 3, that is something that is important to think about. What you need to do is get this partial reaction right here, this 3Fe3 or 3Fe2O3 plus CO yields 2Fe3O4 plus CO2. You need to get your overall reaction to match that. And the way that you do that is by multiplying this overall reaction that you are asked for by 3. So 3Fe2O3 plus 9CO yields 6Fe plus 9CO2. CO2. I'm going to scribble this out. Why can I do this? Because what I'm going to do is I'm going to solve for the delta H of that reaction. Okay, whenever I solve for the delta H of this, well, is that what I'm being asked for? No, it's not. I am being asked for the delta H of this reaction. So how can I take this information right here and get this information right here? Well, you divide this by 3, and that will get you that. Okay, so by starting this way, this problem becomes infinitely simpler. Reaction A, you are not going to manipulate at all. because you have the only reactant that you actually care about, that Fe2O3, because that Fe2O3 is found nowhere else in this overall in any of these other reactions. Now reaction B presents a little bit of a tricky situation because you've got iron, Fe. Fe is found in our overall reaction with a 6 in front of it, and it's found as a product. So what does that tell you about this reaction right here? Well, you're going to have to flip it, reverse it, and multiply it by 6. So I'm going to write flip times 6. So I'm going to rewrite this down here. So 6 FeO. A reactant becomes a product. Plus, or a product becomes a reactant. Plus 6CO yields 6Fe plus 6CO2. My delta H is going to be a positive number, and it's positive 66. Okay, now once I have that information, what I want to do is I want to get rid of any proof of this old reaction. I don't care about that old reaction anymore. Okay, so now when I'm looking at my next reaction, this Fe3O4. Well, I see that Fe3O4. Well, I see that Fe3O4 only in this first partial reaction. Now, what makes this presence of Fe3O4 different is that I don't see that coefficient of 2, but I do see it as a product. Well, do I see Fe3O4 in my overall reaction? Do I see it as a reactant? No, I don't. Do I see it as a product? No, I don't. So what does that tell me about Fe3O4? It tells me I want to get rid of it. Okay. I need to basically come up with 2 Fe3O4 as reactants in order to cancel out the 2 Fe3O4 that are products. So I'm going to multiply this by 2. I'm going to take that delta H and multiply that by 2. So I'm going to rewrite this. 2 Fe3O4 plus 2 CO yields 6 FeO plus 2 CO2. Delta H is 44. Okay. Now, along this journey, you might be looking at it and thinking, oh man, that's a lot of CO2s, that's a lot of carbon monoxides that I'm accounting for. Oh, am I running into trouble on this? I assure you, you're not. Okay. Now, what I want to do once I've done those things is I want to write all of my reactants and all of my products. So looking at the first reaction, this first partial reaction, I've got 3Fe2O3 plus I've got carbon monoxide. But I've got carbon monoxide in all of my partial reactions. So I'm going to go ahead and combine those. There's 1 here. There's 6 here, so that brings me to 7. Plus 2 more, that brings me to 9 carbon monoxides. Okay, now my other reactants are 6 FeO. Okay, plus 2 Fe3O4. Okay, so those are all my reactants and all of my products. I'm going to go ahead and cancel those out, or cross those out. Those are going to combine to produce 2 Fe3O4, looking at my first reaction, done. CO2, there's 1 CO2, but there's 9, a grand total of 9 CO2s. Plus, I've got 6 iron, 6 Fe, plus 6 FeO. Okay, so now before I continue, what I want to do is basically underline. I'm going to go ahead and underline, and now I'm going to highlight. I'm going to highlight the reactants and the products in my overall reaction and where they are in terms of the presence, like are they a reactant or a product, and the coefficient in front of them. I've got a 3Fe2O3. 3Fe2O3. Okay. I've got 9 CO. Got 9 CO. That's awesome. Everything's accounted for there. Now I got to jump across. I've got 6 Fe. I've got 6 Fe. I've got 9 CO2. 9 CO2. This is great. I've got all my reactants and products, and I've got the coefficients, the correct coefficients accounted for. But now whenever I look at my other reactants, I've got 6-FeO. Well, where's 6-FeO in my overall reaction? It's not there. It's a reactant. But where else is it? It's a product. 6-FeO. 6-FeO. It's gone. I've also got 2-Fe3O4. 2-Fe3O4 is a product. This is great. Now what I can do is I can combine all of this, or combine my delta H's, because I've looked at all my reactants and my products, and I'm in good shape there. My delta H for this overall reaction is going to be negative 48.5 plus positive 66 plus positive 60 or positive 44. So that's going to bring me to a grand total negative 48.5 plus 66 plus 44. That is going to get me an answer of positive 61.5. Awesome. Is this the answer? Is this the answer for the question that's being asked? Well, this is the answer for this. 3 moles of Fe2O3 plus 9 moles of CO yield 9 moles of CO2 plus 6 moles of Fe. But the question being asked is, what is 1 mole of Fe2O3 plus 3 moles of CO yield 2 moles of Fe plus 3 moles of CO2? Well, that tells me that when I divide all of these by 3 and divide this by 3, I will get the answer that I want. And my delta H is going to be, it will be divided by 3, positive 20.5. All right. So that is a complicated question, but it's much more complicated when you start it out correctly. So look at those coefficients and think about, is there any work that I can do before I actually get started with flipping and multiplying any of my coefficients? Because whenever we looked at that partial reaction, that Fe2O3, we had that 3 coefficient. Had we not put that 3 in front of there, that would have been a much more rocky and kind of tumultuous process. All right, well, I hope this is helpful. And, oh, sorry. In thinking about this, delta H, positive 20.5 kilojoules. Is this an exothermic or an endothermic reaction? It's important not to lose sight of all of this. Well, that delta H that is positive, that's going to be an indicator of an endothermic reaction. So that means that's pulling heat from the environment. All right, well, I hope this is helpful. Have a great afternoon or evening or whenever it is.